Question number 18a. Describe how a magnet can be demagnetized using the electrical method. So there are several ways of demagnetizing. Demagnetizing means you remove the magnetic effect or the effect of attracting magnetic materials. So using the electrical, so we have the electro method, we have the heating and the hammering method. But in this case, we are required to describe the electrical method. So you say you place the bar magnet inside the solenoid. So you say place the bar magnet inside a solenoid. Facing east west direction, then pass the alternating current. Alternating current through the solenoid. So that is the first step. Then the other one is you withdraw the magnet from solenoid while there is still passing the current, while still passing the current. So this will be able to demagnetize your magnet, and when you withdraw it, it will no longer have the magnetic property. So that is how you do that, demagnetize using electrical method. So that's how you answer that question. Question number 18, part B. You are told you are provided with two iron bars P and Q. One of the bars is magnetized while the other is not. Explain how the magnetized bar can be identified without using a magnet or a magnetic material. So the two bars, for you to identify, you can hang each of the bar at its center of gravity. So the magnetic bar will align itself to the north-south direction. So this is as a result of the Earth magnetic field. So the north pole of that magnet will face the south, and the south pole of that will face the northern direction of the Earth magnetic field, and that way you will be able to identify which one is a magnet and the other which one is not a magnet. The one that is not a magnet will just hang in any direction, so it will not align itself to the Earth magnetic field, and that is how you answer that question. Question number 18, C. Figure 12 shows two identical copper coils X and Y placed close to each other. Coil X is connected to a DC power supply, while coil Y is connected to a galvanometer. So we have the two coils. This is a power supply, this is a coil X, coil Y, and that is the galvanometer. Galvanometer is used to detect, to indicate the flow of current. So we say that, we are told, explain what is observed on the galvanometer when the switch is crossed. So when this switch is crossed like that, there will be a flow of current. As a result of the flow of current through the Coil X, it will induce current, it will induce Y, and current will flow through the galvanometer, so it will deflect. The galvanometer arm will deflect, but once the current in X is steady, there is no flux, then the galvanometer will come back to its normal position. So this means we can write it like this: the hand of the galvanometer, that is rest of the galvanometer, will deflect as a result of induced current, which is double R, current of X to Y. So once there is no flux of magnetic fields in X, the galvanometer, that is galvanometer, deflects back. So that is how you answer that question, and you'll be able to get the correct marks. Roman number 2, we are told, state what is observed on the galvanometer when the switch is open. So what happens to the galvanometer is that the galvanometer deflects in the opposite direction because of the reverse of the current. So the Roman number 3, state what would be observed if the number of turns in coil Y is doubled. If you double the coils in number of turns in coil Y, magnitude of diffraction increases. Magnitude of diffraction of the galvanometer increases because this would increase the current passing through. That would increase the magnetic flux in coil Y, and that would make the magnitude of the diffraction to increase. So that's how you answer that question.